Hello, welcome to another my lecture. So today we're gonna talk about instructions. So what does it mean? So instructions is the ways we use to tell computer do what you want. Yes. So it means if you want computer to do something for you, you need to create instructions. Yes. So how we can do that? So to create instructions, you need three ingredients. The first one is problem solving skills. Yes, it's skills. Next, you need a programming skill. Yes, of course, a programming skill. And then the last one is knowledge of concepts. So what does it mean? I'm gonna talk about this one first. For example, if you want to write a program to compare DNA. So, for example, you have the DNA of the first person and the second person. It's the person 1 and the person 2. So, how do you know two DNAs are similar or not? For example, the DNA relationship between the person 1 and person 2. How can we do that? Yes, obviously, if you want to compare DNA, you need to at least understand what's DNA. Yes, of course. And then the next question is, how can we compare DNA? How biologists compare DNA. Yes. So this one we call, all the thing here, all the knowledge you know about DNA, we call is knowledge of concepts. Yes. So this is the first one. And then when you already know what you need to do now, so you can use problem solving skills of computer science. You will learn about those skills in this course, and then you apply what you know about problem solving skills of computer science to apply here to break down your problem into multiple simple problems. Yes. Multiple smaller problem, we can say that. And then you need to use your problem solving skills to convert the problem to computational problem. Yes. So after you got this one, you're going to use programming skills to convert those problem skills. After you got computational problems, you're going to apply programming skill to solve it. Yes. And implement your solution in programming language. Yes. Yeah, so you know, you need three of them. You need three of them. So you cannot solve a problem if you don't know anything about it. Yeah, of course. So, but even though you know everything about, for example, DNA, but if you don't have a problem solving skills and programming skill, you cannot translate what you understand to something that computer can understand. So keep in mind that you need three of them. Okay, so the next one is we're gonna talk about knowledge. I mean, so keep in mind that it's totally knowledge different from what we already talked about here. We talk about another. I would like to say it's some kind of thinking. Yes, thinking. So that's the way you think. All right. So this what we call a declarative knowledge. So it is what normal people think. All right. Normal people thinking. Normal people. I mean normal people here mean non-programmer thinking. Non-programmer thinking. Yes. Okay. So for example, you can say Earth rotates around Sun. A square root of h. I mean any number h is number y such that y multiply y mean y square equal to h. Yes. However, this kind of thinking cannot provide you a way to translate this problem to what computer can understand. Yes. Do not help you to write code. Or we can say coding, for example. It will help you coding, programming. Yes. Yeah, unfortunately, it cannot help you to solve a problem using this kind of thinking cannot help you to write a code. Yes, of course. And then if you want to program something, you need to have the second kind of thinking we call imperative knowledge. So this kind of knowledge actually is a recipe. I mean, you want to create some kind of recipe to do something. Yeah, you create recipe to do something. So, for example, you want to find the square root of 25. Okay, so how can you do that? In the first step, you need to set j, for example, g will be equal to some kind of value. You can randomly select a value, whatever you want. It's no matter. For example, you can select number 3. If you want, you can select number 10, number 25, for example, whatever you want. Number 100, yes. And then you're gonna to square this arbitrary number. So all right, number 3 square equal to number 9. So you can conclude that now number 9 is not equal to 25. So we can say it's not close enough to 25. Okay, so then you're gonna to set up another value, so the second value, but this time you want randomly guess this value, but you need to follow a formula. So we use number 3 here. We plus 25, it means h here. So divide by number 3, and then you get average. All right, so you can say this formula is, we have h here, it's y. All right, it's h, and then we have y plus h divided by y, and then we get average. All right, okay, so that's it. So now you have another value, you get this number. So this number will be your new guess. All right. So then you're gonna see that if you square this number, you're gonna get 22 something. So you can say that it's closer to 25 if you compare to the first number here. All right, it's more closer. So, but it's still not close enough. So we're gonna repeat the step 3, the step number 3 here again. All right, step number 5 actually just a repeat of the step number 3, and then we're gonna got another number. So you can see that if you square this number, it's very close to the final answer. All right, so we can see that if you repeat one more step, this step, if you repeat those steps one more time, you're gonna get more roughly number that's close to the final answer. All right. Okay. So actually, in here we have some kind we call recipe. It will help you to create a program can find square root of any number h. All right, it's good. I will give you another example here for number 16, so you can see, you can follow the instructions here by I already presented in a table here, so you can easily to follow it. All right, so at the beginning you have number 3 here, so it's not our answer, so you follow the formula, you get another guess. All right, another guess. All right, so we guess 3 here, and then you repeat this process one more time, you have another guess, and then you repeat it one more time, you have another guess. So you can see it's a step closer to the final answer. All right. Okay, so but this one is still not clear enough for a computer because we say close enough. So what does mean close enough? It's quite very complicated to understand for a computer. So you need to define what does mean close enough. It's very simple. You can define using a formula. You can say if we have y here, if y square minus h, and you get absolute value smaller than epsilon number, for example 0.1. So if you can get the difference between the answer and the number h is smaller than epsilon value, so it means the answer is close enough. All right, so it's good. Let's move to the next slide. All right, so we're gonna move to another example about imperative knowledge, but now we're gonna work with the rhyme number. So what does it mean rhyme number? For example, you have number 5. It's rhyme number because it's only divisible by number 1 and itself. All right. Number 2, for example, but number 1 is not prime number because the number 1 is a special case. It's only divided by itself. So yes, so it's not a prime number. So we have number 2, number 5, number 3, for example, number 3, number 7, and number 11. All right. So how can we program? How can we create some kind of recipe to determine a given number h is a rhyme number or not? How can we do that? So let's see my example here. So, before we move to here, I want to explain the idea. So if you have a number 5 here, so you're gonna have a 1, 2, 3, 4, and 5. All right. So we say that number 5 is divisible by number 1 and number 5. All right. So it means in this interval 2, 3, 4, you cannot find any number in this interval e divisible by number 5. Yes, all right. So if you can figure out any number that is divisible by number 5, so it means number 5 is not a round number. All right. So you can say number 5 not divisible by 2, by 3, by 4. So actually, number 5 is a round number. All right. So you can say round number is divisible by itself and 1. So it means in the interval of number 2 and minus 1, you cannot find any number that's divisible by number 9. I'm sorry, number n here. All right. So if we can, I'm sorry. If you cannot find any number in this interval, number 2 to n minus 1, we can conclude that n is prime number. Otherwise, we can say 9 is not a prime number. All right. Okay, how can we do that? All right, let's clear some kind of content here so we can see the slide more clearly. Okay, so that's it. All right, so we have a recipe here. At the first step, we're gonna start with number 2. So g equal to number 2. So we're gonna scan all the numbers in the interval of 2 to number 9 minus 1. All right. So it means when we reach n minus 1, we're gonna stop. All right. So if we still in this interval in here, it means we don't reach this number yet. All right. So we're gonna check we're gonna find any number g in this interval is divisible by number h. So you're gonna see this one. So this one we call modular operator. So what does it mean? So for example, you have 6 modular by number 2. So this means you're gonna have a 0 here. Why? Because 6 divided by 2 equal to 3. So you don't have a remand in this operation. All right, I mean this expression. I'm sorry. You don't have any remand number. So in this expression, okay. So that's it. For example, if you have a number 5 modular by number 2, you're gonna have number 1. Because if you divide 5 by 2, you're gonna have a 2, and you have a remand value 1. Okay, so that's it. All right. So if you have a number h modular to number g, and you got 0, so it means g is divisible by h. All right. So you can conclude h is not a prime number. All right. So we can stop now, because if you can find only one number g, that is divisible by h. So it means h is not a prime number. Just only one is enough. All right. So when you scan all n, I mean when you already scan all the numbers in this interval, but you cannot find any number g that satisfies this condition, so we can conclude that h is a prime number. Okay, it's so easy. All right. So let's start with the programming. So the next one is what is recipe in general. What is recipe? So from observation, you can see here the recipe actually is a sequence of symbol steps. So what does it mean a sequence of symbol steps? So what does it mean sequence? Sequence, it means it have order in here. You have order 1, 2, 3, 4. You cannot extend the step number 2 to replace the position of step number 1, or you cannot move down the step number 1 to step number 2. Alright, you cannot do that because it is sequence. So you have to follow exactly the order of the recipe. Alright, it's similar what the recipe for cooking. Alright, you cannot change the recipe. Alright, I mean you cannot change the order of the recipe. So symbols, so keep in mind that symbol steps, it means it have to be simple enough for computer can understand. Alright, and then oh my god, it cover my content. How second I'm gonna create it. So okay, everything is clear now. So the next one is the follow control. So what does it mean, follow control? So the follow control we gonna learn from some kind of next lecture, so don't worry. Okay, and the final one is you need to know when your program will be stopped. Alright. You can program to run for 14 years to get the answer. For example, you can run your program 100 years to get the final answer, but your program have to be stopped in 1 day. So you need to know exactly when to stop. So you cannot run your program forever. So it's not a computer program. You need time to stop. Alright, everybody. So it's enough for today. So I hope that you can understand what kind of recipe and what kind of thinking you need to learn programming. So in next lecture, we're going to move to some kind of very basic and fundamental of programming language. Okay, see you then.